Okay, so a very good morning to one and all present here. Dear authors and invited guests, welcome to the technical session 3D. Myself Gargi, and this session would be moderated by me. On behalf of Global Knowledge Resource Foundation, it is my great pleasure to welcome you all to the 8th International Conference on Information and Communication Technology for Intelligent Systems, Ahmedabad, India. The eighth edition of this conference is being organized in a hybrid mode. The physical event was organized in Ahmedabad, India on 4th April 2024, and the virtual event is being held through Zoom today, that is 5th of April 2024. I hope you will enjoy the knowledgeable and interactive sessions throughout the day. In this session, we have 10 presentations. Each presenter will be given 8 minutes for the presentation and 2 minutes for the questions and answers. On 7 minutes, I will raise a gentle reminder. There is another request to all the participants that you all stay connected with us till the closing remarks. If you have any query or update, then you can write it to me in the chat box. Just before we get started, I would like to introduce you all to the chair of this session, Dr. Anuradha Yenkekar. She is currently working as an assistant professor. She is currently working as an assistant professor at Department of CSC, Artificial Intelligence, Vishwakarma Institute of Information Technology, Pune. She has published more than 30 research papers, reputed journals with SCIE, Web of Science, Scopus Indexing. She also has published many book chapters and patents. Her research interests include data science, machine learning, artificial intelligence, deep learning, and parallel computing. Ma'am, would you like to say a few words for our audience?
Thanks for the nice introduction, and of course, I would like to give my best wishes for the today's conference to all the participants. Thanks a lot.
Thank you so much, ma'am. So let's start with the presentations. The first paper we have is an approach based on metadata for big data infrastructure, and this will be presented by Veena Jokhakar. You can share your screen and start the presentation.
Yeah, my topic is a metadata-based approach for big data infrastructure. So, as I've actually covered this part of my introduction, I continue with the paper content. So, the introduction is the data quantum today in the whole world has increased to an unimaginable quantum. So the data set that we are having currently in the world is actually requiring a big data environment with a new design and architecture. Okay, the paper proposes the new scalable architecture that will be able to handle the unstructured data, structured, collaborated, and graph-based data. So we are here going to use a concept of Dublin core, that is Dublin core metadata element DCME, and resource description framework, that is RDF. So it is a hybrid mechanism of these two technologies that could be very useful for the designing of data warehouse, that is for the metadata purpose. So data warehouse actually basically contains the task like extraction from the various data sources, transformation, and various other merging operations tasks like concatenating and string based data and data, various files related information for integrations like integration services, report and data mining and crystal reports, etc. For the information display. So now we are going to look at the current trends of warehouse like Power BI. Right now we are having Power BI, Tableau, and other self-service. These are all self-service applications of warehouse. So in this self-service actually is giving us lots of activities, tasks like we can compute everything. We can do the various tasks in the operation itself in the query form, that is called as DAX operation, rather than querying an SQL query in the database OLTP side or OLAP side. So rather it can be done in the self-service side. So these are the various transformation that we can do, and this is for the visualization part. We can plot the various graphs like do plot and pie chart and all other charts that are available. We use it in other crystal reports and everything. The same reporting mechanisms are available over here, along with the multi-dimensional things and all multiple dimensions. So then we have collaborative BI. This is a new, recent new concept that actually integrates business intelligence along with the cloud operations. So that here, this is an example. We can just sign in with an email address and get connected to our cloud, and we can save it in the the reports in a particular cloud. So the current era actually demands real-time data that is actually capturing the data from different sensors. And in industries like health sector, we have various manufacturing industries, etc. So we already right now are having self-service BI and other traditional BI available. So we are now coming up to going to cover the topic RDF, that is Resource Description Framework. So this is actually basically URI. Now here, this URI basically is used for quoting any product, people, item, customer, or anything. If we are able to give an URI to any of these items, or you say we can quote it with an HTTP link or www link, then we say that a particular object is having a URI, it is a URI resource. And uh, so this RDF actually has a description like attributes, features, and relations of the resource, and framework holds the model languages and syntax for the descriptions. So as I said, this RDF was actually published by W3C recommendation 1999, and it is based for the metadata modeling. So right now, RDF is actually used for the security purpose documenting and HTML graph, etc. It is being used widely today. And graph, RDF graph actually has N triple plain text format. So triple exactly is containing the SPO, that is source, source, predicate, and object. Okay, now source actually says that what is the source of the data, what we are having, subject of the data, that is the object that is there in the triplet. Predicate is the actual piece of the data that is there. And we have object, that is the actual value, that is the data. So here we see that this particular colon 8217, this is an example. So here, see, this is the example, this IND 42.5 and 1.6 and NDA. This is our data, core data, and this is going to get converted into RDF. In this, we have it as colon @base, and here this HTTP example client dot CSV is the subject, and this particular angle bracket hash country CD, country code, hash latitude. All these are the predicates. And this IND 42.5, 1.6, this is the object. Okay, so this way, this generates the RDF file. So this way we can actually, we'll look at how our data gets converted to it. So DCME is another concept of metadata. This is also used for the metadata purpose, and this is DCME, Dublin Core Metadata Element. This is also used for the metadata purpose. So now what we are proposing is to combine both of these technologies, RDF and DCME, to come up with a new technology, new way of handling the metadata. So this DCME is a versatile resource.
Sorry to interrupt you. Could you please conclude your presentation? It's almost 8 minutes.
Uh, so, sorry. So I'll just show the framework right now. So these are all the related works that are actually, many people are currently working on it. We can see that I also read that the current big um, companies of IT, they are also working on the same. So many researchers are quoting for the same. So this handling metadata is actually a very big issue for handling this big data. These are related works in this big data. So these are the various works that has been done. The methodology, here we have data from that is collected from various data sources. So you have HDFS and OLTP of HR system, a text data, XML data, real-time sensors, data lake also. This is a new concept that has been just come up in last 7 years. So all of the data that comes is integrated using the Spark technology. The Spark technology is used due to the reason that it is able to handle with data pipelines, and it is a prominent big data in memory processing system. So it is basically used for extraction, transformation, and loading purpose. And here we are using particularly only for the extraction purpose right now, because of the reason that it is able to extract the data from various data sources like text, CSV, Parquet, and JSON. Parquet is also a new technology of data holding from the Apache side. JSON and transaction data, stream data, graph data, everything can be done with the Spark. So we are using it for the extraction purpose only. And then in our model we are going with the we are creating a metadata reference level. So we are creating multi-level reference data for each process in each level when the extraction is taking place. Okay, so the transformation in each level would be different. Okay, so first time, depending upon the features and properties that we are working on, like age of the data, format of the data, type of the data, etc. And finally we can see the visualizations and metadata. Basically now we are actually adding the attributes of DCME and RDF. This is a proposed framework. So DCME RDF metadata is now going to have a new data called as timestamp that is added to it. So we are going to name it as R timestamp. Already our DCME Dublin core DCME is already having 15 core metadata data elements. Along with it, we are adding R timestamp. That is basically to make it qualified uh, and to provide the specificity. Just a minute. And granularity. So we are adding this R time over here. So this is the format of the metadata that we created. We have created date, publication, and all. And our D title means Dublin core title. So these the prefixed with the elements that are prefixed with D are from Dublin, and the elements that are prefixed with R is from the RDF. So we combine both of them, and then we are adding a new R timestamp. Okay, so basically this is Dublin core is going to explain with our data set, and R, that is RDF, is going to give us the details of the particular data set. That's why it has a collection, it has URI and timestamp, it is the details about it. Otherwise the Dublin core is having the specific items of who is the creator and where is the source, from where it is a format of it and all. So here I just discussed it right now. Yeah, so I have discussed this part actually already. I've discussed when I was explaining this
Yeah.
format.
Dr. Veena, can you conclude your topic?
Yes,
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 please.
I'm coming to the conclusion. So conclusion. So DW Enterprise, this particular framework that we have created, it is an enterprise level DW framework, multi-level framework that is called as DCME RDF management for multi sectors. So it can be used with the multiple data sources of multiple types, like from the data sources like data lake, sensor, data graph data, and etc. We can use it. And in the next phase of extraction, the extraction phase, we are using the Spark technology, because of the reason it is much more efficient in for the extraction from the various sources. And then in the next phase we are actually checking the uh, imported data, and we are getting validated it with the metadata of already extracted data from the previous operations of the extraction. And if the data is already existing in the next block of the data, the IDs of the data are read, or else it is transformed to the n number of time transactions. So the data has to undergo the various transformation levels, for which the DCME RDF is already will be again created for each of the step. So each of the step is actually having two parts of the data, one that is going to hold the object and its structure with or without the change, and the other that is going to hold and hold the updated data with a particular level, because the data is transformed in different levels. Okay, so hence we are having going to have both the versions of the data together at the same time. So this can basically be used for the structured data, unstructured data, collaborated and graph based data all over.
Okay, so Dr. Veena, so I can see that your proposed framework has handled, heterogeneous kind of data, means HTML, XML, even text kind of data also. So
Yes.
what changes you have made in your proposed framework so that it is capable of handling such a heterogeneous data?
It is because we are using uh, the first phase itself, we are using the Spark technology. So because of the Spark is already able to cope up with that various variety of data sets. Currently, if we go through the Spark technology and recent technology that has come up, so it is able to handle with all space of data of and types. So the variety of data that we are requiring, it is already there in the Spark. So we are using the same concept here to uh, overcome that particular part.
Okay, so basically you are proposing a framework.
Yes. So that we are combining the Dublin core technology, metadata format, and RDF format. We are combining it, and if we are combining it, we will be able to deal with
Hmm.
the proposed issue of various data sources and handling with the changes of the data.
Okay, thank you, Dr. Veena.
Thank you.
Thank you for your presentation. Let's move to the next one. So the next paper we have is Cognitive Condensation through Adversarial Learning and Ranking in Abstractive Text Summarization. And this will be presented by Priyank Thakkar. You can share your screen and start the presentation.
Yeah, I have my co-author with me, Minakshi. Minakshi, can you share the screen?
Yes, I'm sharing.
Yeah, can you take it to full screen mode?
Hope the screen is visible.
Yes,
Yes,
it is
yes, yes.
visible.
Yeah, so our paper ID is 511 and paper title is Cognitive Condensation through Adversarial Learning and Ranking in Abstractive Text Summarization. This work is done by Minakshi. She is a PhD student at Nirma University and she is working under my guidance, and I am Dr. Priyank Thakkar. Next. This is the outline of our presentation. As we can see, we will start with introduction followed by related work. Then we will discuss about our proposed approach, which is Texum Rangan. Then we will provide the analysis of the results. And finally, we will conclude our paper and provide some future research directions. Next. So as we discussed that our paper is about abstractive text summarization. So first it is important to understand the difference between extractive and abstractive text summarization. In extractive text summarization, you have an input document, and in the summary, it is about selecting the most important sentences from the input document. You do not generate any new sentences. But if we talk about abstractive text summarization, is like understanding the gist of the input document and then using natural language generation technique to come up with the new sentences, which actually represent the summary of the input document. And we are working on abstractive text summarization. Next. So here we present the related work. We had surveyed more than 200 papers, and here we are presenting summary of 5 most relevant papers. As we can see that we are comparing our work, or we are presenting the related work by comparing the existing research on few parameters like what was their proposed framework, what optimizer did they use in the deep neural network, which data set they worked on, which metrics they used to evaluate the performance of the proposed system, and what was their major contribution or the focus. So we can see that we are comparing five papers here. And what we have seen is that majority of the researchers have used CNN Daily Mail data set and RUG1, RUG2, and RUG-L score as the evaluation metrics. And we have also used the same data set and same evaluation metric. Next. So next is, yeah, can you go back, Meenakshi? So this is about our proposed approach. Yeah. So this is about our proposed approach. Our proposed approach is we called it TechSum rank GAN. So basically for abstractive text summarization, here we are planning to use generative adversarial network. All of us know that generative adversarial network consists of generator and discriminator. So in this work as a research contribution, we have introduced a ranker instead of discriminator. Now I'll request Meenakshi to get into details of the proposed work. Thank you.
Okay. Okay. Thank you so much, sir. Uh, Let me discuss the motivation behind, why we decided to employ sentence ranking mechanism in, traditional GAN architecture. So if we talk about conventional GANs, what happens is we train discriminator just to predict binary labels, that is whether the given input is real or fake. So this type of discriminator cannot work efficiently for set of tasks which actually requires to generate the output with rich semantic structures such as natural language descriptions. So we are actually posing certain limits on the learning capability of discriminator. So this can be addressed using rank GAN, where we expect discriminator to learn and assign rank to both human written and machine written sentences just by providing a reference group while training the discriminator. So in simple terms, if we talk, we assign relative rank to every input sentences by looking at a group of reference sentences. So here reference sentences are nothing but they are actually coming from the human written sentences. So every time we expect ranker to look at ground truth summary while ranking the input sentences. So through relative ranking scores, the discriminator can now make better assessment, which in turn help generator to learn more efficiently. So this is the architecture of proposed checksum ranking. So here we can see that we have a generator as a one module and we have a ranker as a second module. So generator is actually implemented using sequence to sequence framework, which contains encoder and decoder. Here encoder is implemented using bidirectional LSTM layers and decoder is implemented using unidirectional LSTM layers. So we have set of input documents which will be given as an input to generator, and eventually generator will come up with a set of generative sentences. So which we call generated summary. If we talk about ranker here, ranker will consider two types of summary here. One is ground truth summary and second is a generated summary, or let's say fake summary. Now here ground truth summaries are actually coming from the human written sentences and fake summaries are nothing but the generated summary. Here one more important component is reference set. Reference set is nothing but the human written sentences. Here comparison set C minus is actually a set of sentences which are coming from the generated summary, and comparison set C plus is a set of sentences which are coming from the human written summary. Now here to discuss the functionality of ranker, we need to consider the two scenarios. First scenario is when when human written summary is given as an input, it also considers the reference set as well as comparison set C minus. So here the task of the ranker is to provide the higher rank to the human written summary and lower rank to the comparison set C minus because it is coming from the fake sentences. Now, second scenario is when generated summary is given as an input to ranker. At the same time, it also considers comparison set C plus, which is actually coming from the human written sentences. So here, the goal of the ranker is to assign higher rank to this comparison set C plus and lower rank to the generated summary. So here, the learning objective of generator would be to generate the sentences such that it will be able to get the higher rank compared to the human written summary, and the learning objective of the ranker is to assign lower rank to the generated summary and higher rank to the human written summary. So now let me discuss about how ranker is actually calculating the ranking score of a given sentence. So first step is to compute the relevance score. Second step is to use the softmax like formula to compute the individual's ranking score. And third step is to compute the collective ranking score. So here first step is relevance score. So it is nothing but the cosine similarity, and that would be computed between the feature vector of input sentence S compared to feature vector of reference sentence U. So cosine similarity between feature vector of input sentence and feature vector of reference sentence. So next step is to compute the individual ranking score. So that will be computed using softmax like formula. Now, the third and final step is to compute the collective ranking score for the given input sentence, and that can be computed using by taking the expectation of input sentence given different sentences coming from the reference set. Now, if we talk about quantitative evaluation of results, so we have
Actually,
used
could
the
you
CNN
please
Daily Mail as a
conclude?
data set. So we are actually having 2,87,226 pairs in the training data set and 11,490 pairs in the test data set. So as we can see in the table, that proposed model Texum Rengen is outperforming in terms of RUG1 and RUG-L compared to all the previous state-of-the-art models as well as the baseline paper. So you can see here, Texum Rengen is obtaining RUG1 score as 41.58, which is higher than all the previous approaches, and RUG-L score is 38.82,
Hello,
which is again higher than all the previous approaches. Yes,
Meenakshi. Could you please
yes,
conclude your presentation? It's almost 8 minutes.
yes, yes, definitely. So the conclusion in future work. So this paper introduced an adversarial network integrated with a sentence ranking mechanism designed for abstractive text summarization. We demonstrated that in conventional GANs, the discriminator is limited to being just a binary classifier, which hinders overall performance. We replaced the traditional discriminator with a ranker and trained the network using an adversarial strategy with policy gradient mechanism. The proposed model, Texum Rengen, was found to be superior to existing methods for ATS, not only quantitatively but also qualitatively. In the future, interested researchers can investigate how to integrate the most recent language models, such as BERT, GPT, T5, into the model pipeline. One can also investigate the architecture of the ranker and generator in more depth and introduce novelty at architecture level. These are the references I have used for carrying out my researches. Thank you.
Yes, thank you. Can you tell us what is the real life use case of your research?
So okay, if we talk about real life use cases, currently IPL is going on. So IPL, if we talk about IPL, if you want to generate the entire highlights, so
Mm-hmm.
of entire 3 or 4 hours of match, we can easily generate through such type of model. That is the one example. Second example is we have a headlines in the newspaper, right? So if we read the headlines of the newspaper, we can easily get an overall idea what would be there in the content of the newspaper.
Mm-hmm. Okay, and how you have collected this data set? Is it from Kaggle or
It is available on the CNN Daily Mail website, and also it
okay?
is available on Kaggle itself.
Okay,
So this is
so
like a benchmark data set. You will find a lot of people using this data set who are
mm-hmm.
working in the natural language processing and
Mm-hmm.
specifically abstractive text summarization. So this is a benchmark and very huge data set.
Okay, I think you have made a good comparative, result analysis. On that comparative result analysis, have you used the same data set on multiple algorithms?
Yes. Means the same setup we have used, like CNN Daily Mail data set was used for comparing all the algorithms, and same train test split was used. And Meenakshi did not point this out, but like we achieved this result in less iterations. Like the original paper required 2,65,000 iterations, while we could achieve this results in 1 lakh iterations.
Okay,
And
but
to be honest, like each
mhm.
iteration was taking hours, so it has
Mm,
taken a lot of time for us to train this. Like it has taken few months for us to train this model. So it
mhm,
was very exhaustive and very large data set, but
mhm.
we could still generate the results.
Okay, for this experimentation, do you need any extra graphics card or TPUs or something? Because you're saying a lot of time is required on all this.
Yes. So like we are from Nirma University, and
Mm-hmm.
we have Center of Excellence in Data Science here, and
Oh,
we
that's
have
nice.
GPU, yeah, data cluster set up here. So like we have 4 800 GPUs. So we dedicatedly spared 1 800 GPU for this.
Okay,
Yeah,
nice.
yeah. Thank you.
Okay, yeah, good work. Okay. Yes, thank you. Thank you,
Thank
Dr.
you.
Priyank, and yeah, thank you, Meenakshi, and all the best for your research.
Thank you.
Thank you.
Thank you for your presentation. Let's move to the next presentation, and it is design and implementation of a Type 1 fuzzy controller driven IoT integrated automated plant watering system for gardening. And this will be presented by Devstuti Biswas. You can share your screen and start the presentation.
Hello, am I audible?
Yes, you are audible.
Okay, I'm sharing this. Good afternoon, esteemed professors, lecturers, scholars, and distinguished guests. Today, I am thrilled to share with you the findings of our research titled Implementation of a Type 1 Fuzzy Controller Driven IoT Integrated Automated Plant Watering System for Gardening, presented at the 8th International Conference on Information and Communication Technology for Intelligent Systems in Ahmedabad. This is a collaborative effort involving the dedicated work of myself, Devsuti Biswas, Arijit Chakraborty, and Prithijit Mukherjee from the Institute of Radio Physics and Electronics, University of Calcutta. So without any further ado, let's begin with our presentation. Before delving into the specifics, allow me to provide an outline of our presentation to give you a glimpse of what lies ahead. So firstly, we will begin with the abstract, followed by a brief introduction to our proposed method. Next, we will provide a comprehensive literature survey, followed by the methodology employed. Finally, we will discuss the developed Android application and along with the designed Type 1 fuzzy logic controller employed in our system. Last but not the least, we have the results and discussion segment followed by the conclusion and references. So let's begin. Abstract. Now, the abstract sets the stage for our research endeavor, offering a concise overview of the IoT-enabled automated plant watering system we developed. It highlights the utilization of an 8-bit ATmega 328P microcontroller, registered soil moisture sensor, DHT11 sensors for real-time data collection, and the implementation of a Type 1 fuzzy logic-based controller for precise regulation. Moreover, the integration of Wi-Fi connectivity enables remote control monitoring via a smartphone application, while ThinkSpeak cloud technology facilitates data transfer and analysis, ultimately optimizing system performance. In the introduction, we provide context by discussing the pressing need for efficient water management in modern agriculture, particularly in light of growing global population and increasing water consumption. We emphasize the financial implications underscored by UNESCO and the significant investment required in water management. Our proposed solution aims to address these challenges by introducing an innovative IoT-powered plant watering system, leveraging sensors for real-time data collection and a Type 1 fuzzy logic-based controller for optimal water allocation. We further detail our contributions, including the development of a cost-effective IoT-enabled watering system, a fuzzy controller for pump regulation, and an Android application for monitoring and environmental parameters. Next. Now, the literature survey delves into the recent research trends, focusing on IoT technologies for water management in agriculture, with a particular emphasis on sustainable gardening practices. We identify key challenges in adjusting watering schedules based on changing environmental parameters and highlight the significance of temperature and humidity sensors in regulating plant health. Various methods integrating sensors and IoT connectivity are explored to enhance resource efficacy and automate watering procedures with blockchain technology integration, enhancing precision and reliability. We reference existing studies and experimentation involving fuzzy logic controllers and machine learning methods, underscoring the relevance of our research within the broader context of smart gardening and water management. Transitioning to the methodology, we provide an in-depth overview of the key components that constitute a system's architecture. At the heart of a system lies the ATmega 3283 microcontroller, which serves as a central processing unit. This microcontroller interfaces with essential components such as the resistive soil moisture sensor, DHT11 humidity and temperature sensor, relay module for water control, ESP826655 module for IoT connectivity, and an LCD display for data visualization. We highlight the pivotal role of the Type 1 fuzzy logic-based controller in ensuring adaptive watering based on real-time environmental conditions, thereby enhancing system efficiency and resource utilization. Furthermore, we present a workflow algorithm detailing the step-by-step process of our IoT-based plant watering system, starting from hardware initialization to data transmission to ThinkSpeak Cloud. So as you can see, the workflow algorithm, which is for the step one is to initialize the hardware setup. Step two is to check the external supply. Step three is to read the sensor readings. Step four is to display the readings on the LCD. Step five is to feed the obtained sensor readings, which is temperature, humidity, and soil moisture, to the designed type 1 fuzzy controller. Step six is to determine a condition that if controller output is equal to watering off, turn off the pump via relay module, else turn on. Step 7 is to establish TCP connection to ThinkSpeak server. Step 8 is to send the data to ThinkSpeak cloud. Step 9 to view the parameters. And finally, step 10, go back to step 3. Moving on. Continuing with the methodology, we showcase the schematic of the circuit diagram and the prototype of our IoT-based plant watering system. The schematic diagram generated using Proteus software illustrates the interconnected components and control logic, providing insights into system wiring, data flow, and operational principles. Additionally, we present a visual representation of the prototype, offering a tangible glimpse into the physical manifestation of our innovative solution. Developed Android application. Now, our developed Android application complements our hardware system, offering users a seamless interface for real-time monitoring of Guardian environmental parameters. Crafted with precision using MIT App Inventor, the application features intuitive front-end and back-end designs, ensuring user-friendly interaction. Interactive graphs provide instant insights from ThinkSpeak Cloud stored data, empowering users with actionable information to optimize gardening practices. We emphasize the significance of the Android application in enhancing user experience and facilitating informed decision making in sustainable gardening. Now, the focal point of our research lies in the designed Type 1 fuzzy control, which plays a pivotal role in optimizing water pump operation for garden irrigation. We delve into the intricate details of the fuzzy controller's design, beginning with the definition of fuzzy regions for temperature, humidity, and soil moisture. So as you can see that the fuzzy regions are defined here with respect to the three parameters, temperature, soil moisture, and humidity, and low, medium, and high are the linguistic values. Now, these fuzzy regions serve as a foundation for defining a set of rules that govern pump control actions based on the interaction among input parameters. We elucidate the structure of the rule base to illustrate the controller's decision-making process. That is, example rules can be like, is temperature is equal to low and humidity is equal to low and soil moisture is high, then pump action will definitely be off. And if temperature is high and humidity is high and soil moisture is low, then pump action will be on. Furthermore, we showcase the reasoning behind inference generation, emphasizing the controller's adaptability in dynamically adjusting watering schedules based on environmental conditions. Refer to figure 6 for an example of a fuzzy rule. Finally, we have the results and discussions wherein we offer insights to the performance and efficacy of our IoT-driven automated plant watering system. The system's ability to capture and store environmental data onto the ThinkSpeak cloud facilitates comprehensive analysis and monitoring of atmospheric changes crucial for garden conditions. We highlight the system's capability in maintaining soil moisture levels and promoting healthy plant growth through efficient pump control following fuzzy rules. The Android application complements these functionalities by providing real-time monitoring of temperature, humidity, and soil moisture, thereby contributing to efficient resource management and reduced water wastage. We enumerate the advantages of our system, including low energy consumption, real-time information availability, cost effectiveness, and an LCD display for essential data, underlining its potential to revolutionize gardening practices. In conclusion, our IoT-based plant watering system represents a significant advancement in the field of agricultural technology, offering a promising solution to the challenges of water management in gardening. By leveraging IoT technologies and advanced control algorithms, we aim to promote sustainability and efficiency in agriculture while addressing global water scarcity issues. We acknowledge the real challenges encountered during the development and implementation phases, including sensor accuracy, reliability of in-speed data, and connectivity issues with a qualified model. However, we remain optimistic about the future prospects of our research and propose potential improvements involving predictive irrigation algorithms and weather integration to further enhance precision and resource efficiency. References. Thank you for your attention, and I welcome any questions or comments you may wish to.
Yeah. So thanks. It was a nice presentation. I just want to ask you, like, how much cost it took to develop your this kind of project?
So, around 500 units, just 500.
Okay. And is there any such system, like, I have not seen, there is no comparison in the results, right? So is there any existing such system available?
Yes, so the definitely our IoT-based working system is better than the rule-based, normally the normal rule-based technology, wherein the fuzzy logic and no type 1 fuzzy logic controller is used. So it is definitely better than that because here we are employed the fuzzy logic controller, which helps us to determine the conditions where there are values can be uncertain or imprecise. And we have in fuzzy logic, as we know, that we can, the variables are assigned different membership functions to determine the degree of membership of a value in that set. So in this way, we can dynamically adjust our working schedule based on real-time environmental conditions, which as opposed to the normal rule-based technology.
Okay. Okay, thanks.
Thank you.
Thank you so much for your presentation. Let's move to the next presentation, and the next paper we have is Object Detection using YOLO 8 and Depth Estimation using Monocular Vision. And this will be presented by Sridevi. You can share your screen and start the presentation. I think she is not present. Let's move to the next paper. So the next paper we have is Predicting Diverse Diseases in Rice Leaves with Convolutional Neural Networks, VGG16. And this will be presented by Nelly Reshma. You can share your screen and start the presentation.
Ma'am, I am the co-author, ma'am. Can I share the screen, ma'am?
Yes, please.
Thank you. My screen is visible, ma'am.
Yes, it's visible.
Thank you, ma'am. Can I start the presentation?
Yes, please.
The project title is Predicting Diverse Diseases in Rice Leaves with Convolutional Neural Network without Transfer Learning and with Transfer Learning. Paper ID is 436. Guided by Ms. Swati Madam. These are the contents I am going to explain today. Rice is one of the majorly cultivated crop in India. It is the second largest cultivated crop in India. It have various diseases affected. The main reason behind I am taking this project is that in our area the rice is mostly cultivated crop. They are facing many issues with the diseases causing to the rice. I have taken two models. One is without transfer learning and with transfer learning. We are using the convolutional neural network, which is related to deep learning. We have taken the sequential model in both of them, and we have used the VG16 model. In this project, when the farmers upload the image of the infected rice, then it will show the disease name and the disease how it can be prevented. These are the papers we have surveyed for completing this project. And the first one is the base paper, rice leaf disease classification using CNN with transfer learning. We have researched almost 15 papers, but only some of the papers we have kept here. This is the data set we have taken from the Kaggle. This is the RiseLib data set. We have 120 MB, and all are in the format of JPG, and the input source size is 64 into 64. We have 4 class labels: healthy, bacteria, leaf blight, brown spot, and leaf smut. And these are the images of the particular class labels. The proposed system we have used the VGG16 visual geometry group. 16 represents the number of layers. Actually, we have divided this into 5 blocks, and each block contains 3 layers: 2 convolutional 2D layers and 1 max pooling layer. And these are the primary layers: input layer, convolutional layer, pooling layer, fully connected layer, and output layer. And this is the architecture. We have used the sequential model. For the sequential model, we have the input layer. In this input layer, we will give the 64 into 64 input, and we will pass it to the convolutional 2D layer, and afterwards we pass it to the max pooling layer. Compared to the existing system, we have increased the number of training parameters so that we will be completed the model within the less amount of time, and we have increased the size of max pooling to 2 into 2, and we increased the convolutional 2D layer kernel size into 3 into 3, and we have increased the number of filters from 16 to 32. And this is the architecture. And the farmer upload the image, then it will be processed in 5 blocks, and it will give the output at the class label. The input image in the format of 64 into 64. In the block 1, we have 2 convolutional layers and the 1 max pooling layer. As same follows for all the blocks, and there are 3 fully connected layers: flatten layer, dense layer, and the soft max layer. After all this processing, the farmer will get the disease name and how to prevent it. And this is the website. We have used the Django framework. In this Django framework, we have used the MVT pattern, model, view, and template. Templates are nothing but the HTML pages. Views are nothing but the functions we have used in the Django framework. Models are nothing but the Python files, because Django is in the Python format. We have used 2 models. One is with transfer learning, another one is without transfer learning. With transfer learning, we have got the highest accuracy of 95.6. Without transfer learning, we have got the accuracy of 85.6. With transfer learning, it is always better, because we have ImageNet data set, ImageNet database. In this database, we have millions of images. The VG16 model is pre-trained on that particular ImageNet database, so that while using with transfer learning, you will get a better accuracy, and it will be helpful for the farmers. And these are the results. When the farmer upload the image, when they click on submit, they will get the results like rice disease predicted as brown spot, and the leaf blast and leaf knot and healthy. There are so many existing papers on this already, but we have achieved the better accuracy than all of these papers. The previous, there are only a 92%, but we are getting 96% accuracy. And compared to other models, we have less training time and less number of parameters. And within the less number of layers, we have achieved a good result. And these are the references I have used in this for this paper. I am completed now.
Okay, so thank you for the presentation. Basically, I was wondering, like, the data set which you have used um is around something 120 MB
Yes,
something.
ma'am. Yes, ma'am. 120 MB.
120 MB, and number of images are 160. So I feel this is very, small data set for
No, ma'am.
transfer
Yes,
learning
ma'am.
concept.
Yes, ma'am. It is very small data set, ma'am. But we are using the image data generator, ma'am. In this image data generator, by using the by by not taking the image from the outside, we are using these images, and we are using the auto scaling and rotator and image generator, and we are changing the angles like 90, 180, 270, 360, and we are changing the angles, and we are generating the new images from this existing images, ma'am. We are not taking another images, ma'am.
Okay, so then what is the data set size of after generating?
And after generating, it is like 1.6 GB. It's like, ma'am.
Okay, and also I have not seen, means just take it as a suggestion, like since you are saying that you have got 96% accuracy,
Yes, ma'am.
and others have not received that much, right? So that comparative result analysis I have not seen in your presentation. And along with accuracy, you can check with even other parameters also. So performance evaluation of such a transfer learning should happen with multiple parameters, not only on the basis of accuracy.
Yes, ma'am.
Okay. Yes. So all the best for your research. Thank you.
Thank you.
Thanks.
Thank you, Bharat, for your presentation. Let's move to the next paper. And it is Review of Deep Learning Techniques for Lung Cancer Detection. And this will be presented by Swapnil Andharia. You can share your screen and start the presentation.
It's visible and audible.
Yeah, visible, audible. Please go ahead.
Okay. Good afternoon, Professor Anuradha ma'am and all dignitaries present over here. Today I am going to give the presentation of a review of deep learning technique for lung cancer detection. It was prepared by me and my guide, Dr. Hemant Patel. These are the outlines of my presentation in which I will cover this number of contents in this presentation. Title, abstract, introduction and its type, introduction of AIML and DL, detection of early stage lung cancer nodule, framework and proposed approach, discussion and analysis, lung cancer detection method comparison, conclusion, future scope and bibliography. This is the title, Review of Deep Learning Techniques for Lung Cancer Detection. In this paper, I have find so many number of papers, and I have identified and I have prepared a review about the lung cancer detection in early stage. This is the abstract of my review paper. One of the most challenging and elusive form of cancer is the lung cancer. We all know that because nodule typically result in mortality in both men and women. It is critical to check them as soon as possible and accurately. As a result, numerous techniques have been created to identify lung cancer at an early stage. These studies compare, compare the various early detection techniques based on machine learning and deep learning. Several methods have been developed in recent years for identifying lung cancer. Through some also use X-ray and CT scans are employed by the majority of them. And image recognition is used to find the lung tumor nodule using a variety of segmentation and classifier methods. This study discovered that the majority of the CT scan images used for the cancer diagnostics are better suited for the giving accurate results. The result of this method are also more accurate when compared to marker control watershed segmentation, which we have used watershed segmentation also. The result of deep learning techniques were more accurate than those obtained using conventional machine learning technique. This is the introductions in which I have described the introduction of lung cancer. Lung cancer, as we know that we consider as the deadlier disease and the primary concern of high mortality rate in present world. Lung cancer affects the human being at a greater extent, and as per prediction, it now takes 7th position in mortality rate index, causing 1.5% of total mortality rate, means total death, 1.5% of total due to lung cancer in the world. So lung cancer originated from the lung and spreads up to the brain and affect complete body. Lung cancer is categorized into two major groups, means it is classified into two types, small scale.
I'm sorry, but can you go to your work like maybe
Yes, yes,
post?
yes.
Yeah.
For that, can these I explain types of lung cancer? These are the non-small cell lung cancer, and second one is small cell. These also did not I do not want to explain. Directly we go to the work. Detection of early stage lung cancer nodule. As we all know that if we find the lung cancer nodule in early stage, then the mortality rate can be decreased. So um, this figure shows that the 2D CT scan image in which you can see that the small early stage cancer nodule is present over here. Uh, 1 minute. Hmm. Uh, In this example, early stage lung cancer nodule seen in a 2D slice of CT scan image, and here we have to apply the image pre-processing and malignancy classification detection, and nodule candidates are our classification pipeline by analyzing CT image, means CT scan image built by artificial intelligence approach. Machine learning technique help in the early diagnosis and evaluation of lung nodules. This is the framework which is used in this paper. In this framework, you can see that there are the mainly three phases: pre-processing, training phase, and testing phase. These systems are referred to as the decision support system that examine the images through the process of pre-processing, segmentation, feature extraction, and classification, as shown in the figure. This system help us to design and evaluate the lung nodule as early as possible. So we also have other systems that looks at the CT image and use the artificial intelligence approach to detect the defect nodules and other malignancies. So here I have used the convolutional neural network, deep learning techniques to identify the lung cancer nodule in a detail. This is the proposed approach. The prediction of lung cancer prone patient will a doctor in their treatment decision making. In this respect, in the attempted to measure the discriminative capacity of multiple predictors to improve the efficiency of the diagnosis of lung cancer by their symptoms. So a variety of classifier here used to tested on a benchmark dataset retrieved from the UCI repository, including the auto NLP, natural language processing, naive-based classifier, support vector machine, decision tree, gradient boosted decision tree, neural network, random forest, and other classifier. It is noted that the gradient boosted tree exceed other as individual as well as the ensemble classifier on the basis of performance assessment and achieved the 90% of precision. This is the discussion and analysis. And this research is mainly focused on the deep learning technique used to identify the lung cancer. However, a number of studies, literature work did make use of X-ray and CT scan image. In all scenarios, the steps for recognizing lung cancer are as follows. First is the pre-processing, and second one is classification. This we have already discussed. This is the pre-processing step, and this is the classification. Classification is further divided into two parts: training phase and testing phase. So in pre-processing, it is the first phase in which the CT image or the X-ray image is taken as an input. Then some techniques of the image processing will be applied, such as we all know that the pre-processing technique like denoising, thresholding, binarization, normalization, and zero centering techniques we have applied over here. Then followed by the segmentation that will segment the similar and dissimilar regions from the CT scan image. Then after many segmentation methods such as region growing, marker control watershed, and marker control watershed with the masking have used in this literature. Here I have used the marker control, the watershed with marking segmentation, and finally the features can be extracted to be prepared for the next step, which is represented by the classification. We know that the classification is divided into two parts. First is training and testing. In this way, the extracted features are fed to the specified classifier to classify them as a normal and malignant accordingly. Many classifiers have been used by the researcher, such as the multi-layer perceptions, SVM, naive-based neural network, gradient boosted decision tree, etc. From table, it is clear that highest accuracy result is 97%. That table I will discuss in the next slide. provide multi-class SVM classifier as well as adopting the marker control watershed based segmentation for image segmentation. On the other hand, all the other works that have been implemented using the deep learning methods obtain high accuracy result, where the highest result was about the 99% using the multi-resolution page-based convolutional neural network. These are the lung cancer detection method comparison. I have searched so many papers, but in this presentation I have include only 9 papers in which we can this is the comparison in which we can see that in this first paper, the pre-processing step I use is the lung field segmentation and deep suppression, and method used was the CNN, and data set used was
Okay.
Japanese Society of
Yes, can you please conclude your topic?
yes. So, conclusion, it is wise to begin treatment as soon as possible if you suspect you may have the lung cancer to lessen a likelihood of a side effects. This study examined, this paper summarized that a detailed survey on various machine learning approaches to classify the lung malignancy using the CT image or X-ray image. Also, many classifiers used such as NLP, SVM, naive-based neural network, gradient boosted tree, decision tree, etc. It can be concluded that the method which is utilized using deep learning technique obtain the higher result in terms of accuracy than the other classifier, other machine learning classifier, and where the highest result was about the 99% of accuracy we got in multi-resolution patch-based CNN of convolutional neural network. This is the future research scope, and these are the number of reference I used to construct this paper. Thank you.
Okay, so I just wanted to ask you one question. In this entire experimentation, where was your own contribution? Means, uh, in the phase of data gathering, or you know, I have not understood.
Mean these all in this review paper I have identified many number of papers, and just I combine those paper and make the review. So by using this review in my thesis work, I will use the convolutional neural network in further, and for that I have used CT image and X-ray image both, and we combine both image to get the result. Up till now, I have used only the up till now the research have been done in a binary data set. I will use for my thesis in using the CT image and X-ray images using
But
CNN method.
yeah, but convolutional neural network is now it is little behind because there are a lot of advanced machine learning, deep learning, transfer learning algorithms are there now.
Yeah.
So why don't you think about that? Because when using convolutional neural network, you may not face to the current market trend regarding the achieving the performance.
Up till now, I have no more idea about the recent trend. I will definitely try.
Okay, instead of convolutional neural network, there are various variants like depth separable convolutional neural
Yes,
network
feed
or
for that.
transfer learning, BERT, Robert,
Yes,
various variants of BERT model.
yes.
Even
I will definitely try that
yeah,
variant
sure.
used to make the research more strong.
Yes, yes. Okay, so nice work. Thank you.
Thank you.
Thank you, Swapnil, for your presentation. Let's move to the next paper. And it is Surveying Document Management System, the impact of user experience proficiency. And it will be presented by Kashvi Kaushal. You can share your screen and start the presentation.
Is my screen visible?
Not yet.
Mm. Now,
Yes, it's visible.
okay, good morning, everyone. Good afternoon, everyone. My warm regards to our session chair and all my fellow presenters. Myself, Kashvi Kaushal. I am a postgraduate student at NIET, and my topic for today's presentation is Surveying Document Management Systems and the Impact of User Experience Proficiency. This is the brief outline of my presentation. So, what is a document management system? It is a computerized system that stores, shares, tracks, and manages documents. We can take examples like Google Drive, Dropbox, OneDrive, Adobe Document Cloud, etc. It is used to store our documents securely, save manpower, and access documents easier. It's easy to maintain, and also customization is easier, reduces cost, and also reduces physical storage. And what does user experience proficiency mean in DMS? User skills and familiarity levels with navigating and utilizing DMS interfaces and features are vivid to every user. It ranges from novices needing guidance and to experts proficiently leveraging advanced functionalities. So it is very crucial for to design user-friendly interfaces and providing appropriate support to enhance overall usability. The role of SMI has very largely increased in the past years. The market size reached USD 5.40 billion in 2021, and the Kagar report registered a 11.2% for increase. The basic challenges posed by small and medium enterprises are limited resources, insufficient document organization, data security concerns, scalability concerns, etc. Additionally, Additionally, there's regulatory requirements and managing the growing volume of digital information. So overall, addressing these challenges is essential for SMEs to remain competitive and thrive in digital era. Here I have analyzed the top functioning DMS platforms. First one is Google Drive. Its key features is integration with Google Workspace and is very user friendly. The challenge here is organizing large document repositories is very difficult. So your recommendation here is to improve folder organization and user education. The next one is SharePoint. Here, the key feature is robust collaboration features, and the this is also a challenge because normally in SMEs a lot of collaboration is required, and here though it is a key feature, it is not that successfully implemented. Next is Documentum, which is it is a enterprise level document management system. It is very difficult to navigate for new users, and because of the less intuitive UX design and enhanced training is required to navigate through it properly. The next one is M Files. It is a meta driven organization, and it accommodates users well, but further customization options are limited. Also, we have Dropbox, which is very easy to use and offers file synchronization across devices, but data security and version control is an issue. Next up is OneDrive. It is a Microsoft Office software, and uh, user transitioning is a challenge here. So clear user guidance is required, and customization options are also required. Next up is Adobe Document Cloud. It is a document creation, electronic signature, PDF editing software. Its usability concerns in complex workflows and integration. So major findings here is that diverse usability challenge across user proficiency levels is required, as it gets very difficult for new users to navigate through basic software, while experts may face issues with advanced features and customization options. Also, there is a large importance of customization and training that is required in these softwares. Next up, balancing simplicity and complexity in DMS interfaces, because they need to be simple enough and still offer every features that is required at enterprise level. User-centric designs need to be included in order to enhance usability, and use of various user-centric designs principles also need to be included. Uh, Interdisciplinary collaboration in addressing usability challenge is also required to tackle complex usability challenges within DMS. Um, so, what are the implications and findings for DMS developers, organizations, and users? DMS developers need to prioritize user-centric design principles to enhance DMS interfaces, implement continuous improvement strategy based on user feedback and usability matrices, and foster interdisciplinary collaboration to address complex usability challenges efficiently. Organizations need to invest in DMS platforms that prioritize UX and offer customization options, and encourage user feedback and participation in refinement of DMS interfaces. For users, they need to advocate for intuitive DMS interfaces that streamline the document management processes, and participate in training programs to enhance proficiency and productivity in using DMS. So, in conclusion, in today's rapidly evolving digital landscape, DMS interfaces must evolve in uh, tandem with changing user expectations and technological advancement. User centric design principles play a crucial role in shaping DMS usability and ensuring the interfaces resonate with user needs and preferences. Moreover, the importance of continuous improvement and adaptation cannot be overstated. In conclusion, this research paper has shed light on nuanced relationship between DMS usability and user experience proficiency within SMEs. So, by addressing the identified challenge and leveraging opportunities for improvement, organization can maximize the value of their DMS investments and empower users to effectively manage and collaborate on digital documents. These are the references, and thank you.
Okay, so what could be the future possible work in this domain?
Ma'am, basically, we need to identify. There are very limited document management systems available as of now, because the need of uh, DMS softwares has profoundly increased in the last 10 years or so. So we
Mm-hmm.
need to work on the user engagement and user interface design in order to decrease their complexity and make them more user intuitive.
Okay. Okay. Yes, thank you.
Thank you, Kashvi, for your presentation. Let's
Gargi, I think we can limit to the time.
Yes, ma'am, sure.
Yeah, please.
Okay, so let's move to the next paper. And it is Chair AI Nexus by Kushagra. You can share your screen and start the presentation.
Okay, 1 second, I'm sharing. Hi, can you see my screen?
Yes, it is visible.
Okay. So a very present good afternoon to one and all in this meeting. I, Kushagra, on the behalf of Team TERI Nexus, is here to give the presentation about TERI Nexus, about the paper ID 497 for the ICTIS Conference 2024. Before starting this presentation, I just want to tell this, we all have something in common. Though we are coming from different colleges, different places, different professions, you know what? The love for the country and the love for the army. But do we know that the Indian army has faced a lot of challenges and still facing when it comes to terrains. The surveillance of perilous terrains poses intricate challenges for military personnel, may it be navigating through landscape or unpredictable weather or the potential adversary threats from neighboring enemy country. But in response to these challenges, we introduce an innovative monitoring system, Ter-I Nexus, the terrain AI, the perfect amalgamation between the machine and a man that has the perfect advancement in robotics, machine algorithm, and cloud computing. The system is designed to facilitate real-time surveillance and object tracking in rugged terrains. Our approach integrates the state-of-art computer vision techniques to effectively track and identify objects. Our aim is to equip soldiers with essential tools for effective and efficient operations, even in the most demanding environment. Our works, let's just talk about the literature surveys. We have some authors of Yin and Yu, which made this state of the art vision based object tracking and detection. They provided a very solid foundation for accurate soldier identification. They did it in the South Korean soldiers. We tried to do it in the Indian army. They take motivation from vision based objections. D-Wing in her work also had the performance of the four deep learning models, namely a fully connected model, a custom CNN, MobileNet V, and MobileNet 2. They have this higher training times, but they have the higher accuracy of 92%, 93%. The vision based object detection and tracking finds implications in surveillance and navigations. It has a concise overview of its history, methodologies, and the state of the art technologies. What is our main objective is, so we want to propose a monitoring system that can keep surviving the area. Also, it's smart enough to differentiate between the enemy and the Indian soldiers. We want to also make the system capable enough to aim and shoot with the target with proper accuracy. Not only that, we also wants to develop an interactive software through which the soldiers can control the devices through their phones and also get the live updates regarding the system remotely. Let's just quickly go through the methodology part. So the paper were divided into three parts: the embedded system, the image segmentation, and the software development. We, coming from the BTech from Electronics and Communication Department, we take immense pride in developing the embedded systems, which will be helpful for catching the footage in the current locations, which, for the movement of the gun and aiming to the negative PID feedback loop. Then comes the image segmentation parts, where we're going to deploy the effective ML algorithm, which is going to, use the pattern recognition formula for detecting of the uniforms of the army and detect which is the Indian army and the neighboring enemy army. And then we have the software part, the more important part, where we are used to create interactive environment using your application interfaces, maybe Flutter or something. So we will able to include the location, the live footage, and even an option for confirmation of shooting from the user. Then roughly briefing to the components in the software. For the embedded systems, we have a microcontroller, of course, a ESP32 cam for the camera regions. We have the Bluetooth module HC05 for establishing the connections. We have the motor driver, which is used to give the power to the body. And then we have the system to rotate and aim for the car body to move. For the image segmentations, we have Python, and we are using ML algorithm to track the enemy soldiers. For the software developer, we are using Flutter and the Dart language to create the applications. We also have opted Google's Firebase as the cloud storage in our project, and all of those commands of the microcontroller have been written well in Arduino C. Let's just quickly talk about the system designs. The system will consist of various processes. The first one is the pattern recognition, as we have talked about. So we are utilizing an efficient ML model for pattern recognition, the primary objective. We have using your both type of supervised and unsupervised algorithm. For the supervised one, we have suppose vector machines, which enhances its capacity to handle garment with intricate designs and accuracy, distinguish between the plates, types, patternless and irregular patterns. And for unsupervised algorithm, we can deploy KNN also. The pivotal phase in the pattern recognition would also be the feature extraction, where each image will possess distance qualities that will serve as the basis for analysis, and various algorithm plays a very crucial input. For example, the statistical features, the scale invariant features, transformation, the GCLM matrix, or it be your radon features, and many more. Then comes the most important part, which is the body directions, in which we are incorporating a media pipe, which is a framework developed by Google for constructing ML media pipes. What actually media pipe is all about is nothing but it's a computer vision technology that uses a deep neural network to estimate the human body poses from image or video. The algorithm is based upon the idea to detect key body landmarks or key point and estimating their positions in the 3D landscape, as you can clearly see in the figure, which shows the 33 landmarks the media pipe can be able to detect. This uses a machine learning model called the Blaze pose to recognize the human body pose. It's a lightweight and accurate model developed by Google. So how does it actually works? It breaks down the vision pipeline into series of modular stages, each of which can be customized to suit the specific needs of the applications. These stages are then represented by the series of nodes, which are connected together to form this type of graph, as you can see in the figure. These nodes in the graph, they represent the different stage of vision pipeline, such as image acquisition, feature extraction, and classification, which we have already talked about. Also, Google's Media Pipe utilizes cutting-edge technology in incorporating features like face detections and pose estimations. Now comes the part which is the live imaging through applications and shootings, as we have clearly detected the obstacle or the army or the enemy. Then comes the part of keeping the user, in our case the Indian Army, informed about the ongoing activities without requiring their physical deployment near the turret. To address this, we are using an application based Flutter initially that will stream the camera output to the app using an ESP32, and there will be live footage on the web server. We are using Google Media Pipe for that. In case of successful pattern detection, the app will generate a notification requesting permission to shoot.
Yeah, Kushagra, yeah, can we go to the like what results you have achieved?
Oh, sure, ma'am, sure.
Yeah, please.
Sure, ma'am. The next part was the implementation part that we have achieved. So as you can see that our team has all of the engineers. So we basically designed these changes. We can see that we have your ESP cam, we have our motor driver, we have a Bluetooth module for that, and there is the connection that we have drawn and how this is going to work. It's all being written over there, the microcontroller, the internet, the Bluetooth, the ESP, how they're going to connect, and how they're going to incorporate the data given to the your Flutter based application. So how this flow of the data is going to take place is well being written over there. Then what we actually did, we had some data sets, so we have to use the your media pipe human body recognition. So that's what is being written over there. We can say that, for example, suppose this is the original human picture, so detection is to be done. So stage 2 is nothing, but we are leveraging the media pipe that allows us to confirm the existence because it recognizing the 33 landmarks on the detected human being. Then comes, as we can see that, okay, also we did something was that we really do not need all of the 33 landmarks. Instead, we can work out with all the 4 chest landmarks. As you can see in this picture, let's just see there's 4 landmarks as x1, y1, x2, y2, x3, y3, and x4, y4 that forms a 4-sided polygon. And you can calculate the center of the polygon as x1 minus x2 by 2 and y2 minus y4 by 4. And this calculation can be performed for points in an images. Since a video is nothing but essentially a sequence of images, analyzing each frames allows to obtain a still images and easily calculate the body center through 4 detected landmarks as demonstrated in this figure. Then this is the interface of the app that we actually designed. So we want to connect it with the Firebase clouds in the application. So we made it using Flutter. And this is all where all of those screenshots will rapidly go and see. So we are also giving a button to the users that allows them to take a snapshot of any given moment and store it into Firestore. The snapshot can be assessed whenever required, as you can see in the figure below. So does this model have a social impact? Yes, it has. Not only it enhances the safety of military operations, it minimizes the risks to the personnel, but also provides them in dealing with decision making through real-time threat notifications. Also, they can control it remotely via mobile devices, enhancing the flexibility and accessibility in monitoring hazardous terrain. Furthermore, the incorporation of cloud computing ensures scalability and marks a significant investment in intelligence monitoring system. Conclusion. So in this paperwork, we introduced not only a cutting-edge defensive talent system for the recognition of potential threats, real-time tracking, and control engagement, but also it provides a seamless monitoring through a user-friendly smartphone applications, granting them authority over the terrorist shooting activities and the options to capture snapshots at their discretion. Scope from improvement. So the furthermost could be the incorporating of microphone and different channels, elevating user by enabling virtual communications. And then later on, we can also, what we can do is we can extend the system's capability by integrating into a drone platform. It will not only increase the mobility, but also grant the users freedom to exercise control over his movement over a widely spread negative terrain area. These were the references, and we thank the ICTIS conference for presenting our paper here.
Yes, thank you, Kushagra, for the nice presentation. It was really nice work.
Thank you,
Uh,
ma'am.
So yeah, no questions from my side. We can take up the next one.
Okay, thank you.
Thank you, Kushagra, for your presentation. Let's move to the next paper. So the next paper we have is the analysis and integration of diverse data sources for decision-making process of big data. And this will be presented by Shailesh. You can share your screen and start the presentation.
Sure, ma'am. Thank you. Is my screen is visible?
Yes, it is
Yes.
visible.
Yeah. So good afternoon, everyone. I'm research scholar Shailesh Gahane, working as an assistant professor in School of Allied Sciences, Datta Mege Institute of Higher Education and Research, Savangi Mege Varda. So my paper ID is 356, the analysis and integration of diverse data source for decision-making process of big data. So the contents of this PPT are introduction, literature survey, research gap, need of study, objective of research paper, research fact findings, and the conclusion. So here the introductory part. So here the big data is simply refers to the extremely large amount of data using 5 V's. The typical data qualities can be explained over here. The digital security is one of the most crucial elements today. So security is visually essential when dealing with the use data, since it contains the private information, code words, password, and that if compromised might have disastrous effect. So when contemplating big data and the cloud computing and the security issues are very much crucial in this regards. So this system nodes for authentication, encryption, access control, etc. may run into the number of issues, including one of the evolving data storage transmission, security processing, and the quality. So here in this paper, I have contributed towards the cloud computing as well as big data have an application in a variety of industries, including. So basically this research paper focusing on the various patterns of big data, the big data collaborations with cloud environment, and the big data processing in the data science field. So through this paper, we are proposing the different issues and challenges of big data in the cloud environment. The basic objective of this research work is to know the challenges of integrating and analyzing the different data sources and the consents of the respondents about their organizations for experiencing in big data. Here, the second objective is to know the respondent strategy on big data and the data analytics and the usage of big data analytics to improve the decision-making processes in their organizations only. And the third objective is to know the investment usage of big data analytics in the organization and the collection of storage of data from different various sources. So basically, if we talk about the research literature review, here I have find it out near about 35 papers over here, and I have referred total 26 papers over here. So basically in this literature review, the first paper talks about the cloud computing and the big data analysis, what is new from database perspective. So basically in this study, the finding of this paper is explanation about issuing the evaluating large amount of information for both stationary and the moving material. And the remark of the scholar is long running queries for both decision assistance and the analysis that consumes and perhaps generated a lot of data can be run on the Hadoop database system. Here we have talked about the HDFS file system, that is the second literature review based on the Hadoop based secure storage solution for big data and cloud computing environment, digital communication and networks. So in this paper, the paper allows to distribute the different names provided by the numerous data sources, as well as this paper combines the HDFS Federation, that is called as Hadoop Database File System Federation, and to accomplish dual channel storage over here. So basically the remark of the scholar is we looked at how big data storage using the Hadoop architecture would be impacted by the security of data blocks and the dependability of the metadata, and the imposed a secure and effective solution over here. Third literature survey talks about the addresses of the benefits of disadvantages of adopting cloud software for large data processing. Additionally, it offers throughout the analysis of the available large-scale data platforms, categories, and according to the big data specific standards. So the remark of this scholar is the cloud computing is a promising option for this purpose, and even though conventional storage and the computing solutions cannot fulfill the requirements in the big data applications over here. The fourth literature review is talks about the big data storage system. That is, again, we have taken the example of Hadoop technology and their connections to the cloud computing, and I'll discuss over here. The remark of this scholar is the development of the cloud processing of big data as well as the traits and the categories over here. Now, next two literature survey deals with the different cloud computing areas as well as the different Hadoop technologies over here. So here sixth paper talks about the review of the difficulties with the cloud security and the privacy. So we intended to stimulate additional research on the security issues in the cloud computing by utilizing the case study to illustrate the significance of the security challenges in the cloud computing as far as cloud computing security is concerned. So the remark of the scholar is cloud computing is an emerging internet-based technology, tends to be dominant computer science and the information technology applications involving large-scale network computing over here. So here, according to the literature survey, the research gap which we have identified, the research gap with big data and cloud environment is the big data paradigm bitted by pay-per-use feature, data
Is there,
sharing,
yeah,
scalability. Yeah.
sorry to interrupt you. Is this only a literature survey work, or you have proposed any framework or
Ma'am,
algorithm?
we have proposed a survey-based work over here.
Okay.
From last 8 months, I have been working with the big data because my PhD topic is related to child healthcare system. So for that, I'm collecting the different data, and I'm working with the cloud computing as well as the big data. That's why I have proposed this paper over here.
Okay.
So,
So from where you are collecting this data?
Ma'am, we have visited near about 100 companies, 100
Mm-hmm.
the companies which are related to the healthcare industries, like
Mm-hmm.
DY Patil College, Pune Medical College, then DMIHR, it's our university over here. Then we have visited to the Lata Mangeshkar over here. So there is a information technology department, like we are going to call it as a EDP section over there. Okay, ma'am. So through that particular person, we have collected the different types of data, and here we have contributed, and here we have reached to that particular objective. So there are different challenges related to big data, related to cloud computing also. And in the next, and in this is what my research fact finding. So here we have prepared some questionnaire about the organization and how they are going to deal with the big data as well as with the cloud computing. So these are the some research questions which we have find it out according to the objective, ma'am.
Mm-hmm.
So
Okay.
here the
Okay.
yeah, ma'am.
Is there any data analysis?
Yeah, ma'am. There is a data analysis, but in this paper we are only proposing the research fact finding techniques over here. Here
Okay.
I am talking.
Okay.
Yeah,
What
ma'am.
kind of data attributes are there?
Here the different data like the patient address is there, patient name is there. Then according to that particular data, we are going to do the data prediction analysis kind of thing. So I'm going to design one of the framework which deals with the decision support system. According to the symptoms, our framework is going to give the suggestions, as well as our system is going to give the proper mechanism to care the particular system related to child healthcare, ma'am.
Mm-hmm. Can you go to the proposed work now?
Yeah. So this is what my research fact finding. So the first question is to the information technology department. To what extent does your organization have experience in
Okay,
big
this
data?
understood. Can you go to the proposed work?
Yeah. So these are the research fact findings. Total 8 questions I
Mm-hmm.
have been gone through this, and out of 106 companies, ma'am, 72 responses I got over here. So based on that particular data, the conclusion of this research paper is to we have discussed and we have taken the actual fact about to know the challenge in interacting and analyzing the different data sources. Here we have used the word, ma'am, diverse data sources. Why? Because these 106 companies are using different type of data sources. One of the company using Hadoop data source, one of the company using Excel data set as a data source. So that's why we have used over here diverse data sources, and the consents of the respondents about organization is experiencing in big data. So we have to know about the respondent strategies on the big data or the data over here, ma'am.
Okay.
And these are the total papers over here. So based on these 26 papers, ma'am, we have selected the 26 papers. Actually, we have referred the near about 35 papers over here. And based on that particular survey, we are going to conclude over here.
Okay. Yes.
That's it, ma'am.
Okay. Thank you for the presentation.
Yes, ma'am.
Yeah, we can take up the next presentation.
Okay.
Yeah.
Thank you
Thank
for
you,
the
ma'am. Thank you so much, ma'am.
So let's move to the next paper. And it is the impact of generative AI in modern education system in India. And this will be presented by Pankti Bhatt. You can share your screen and start the presentation.
Yes, ma'am. Is it visible, ma'am?
Yes.
Good afternoon, one and all present here. My name is Dr. Pankti Bhatt, and today I'm going to present on the title, The Impact of Generative AI in Modern Education System in India. And these are my co-authors. They are Dr. Jignesh Kumar Chauhan and Mr. Dhaval Naval. The topics which I'm going to cover, the contents are like introduction. What is the current education system right now in India? Use of generative AI, advantages, the challenges which are faced, conclusion, and references. Now, in recent years, the integration of generative AI has significantly transformed various sectors, including education. In India, where the education system is vast and diverse, the adoption of the AI technologies promises to revolutionize teaching and learning methodologies. Now, what is generative AI? Generative AI is a subset of AI that focuses on generating new content, has particularly gained a lot of attention for its potential to enhance educational practices. It is instrumental in automating content creation processes for educators. This includes generating diverse education materials such as lesson plans, assessments, and interactive simulations, freeing up valuable time for instructors to focus on fostering critical thinking and interactive discussion. A generative AI in education represents a revolutionizing shift in the traditional education paradigm. Through personalization, content creation, and adaptive support, this technology has the potential to significantly enrich the learning experience provided. It is implemented responsibly with a focus on ethical considerations and the preservation of educators' essential role in shaping well-rounded individuals. The current education system in India, now it has been divided like comprises of several stages like preschool. It starts from like age of 2 to 3, and that is like it mainly focuses on emphasis on like play-based learning and language development, crucial for nurturing early cognitive skills. Second is like school stage. It starts from the year of like from 3 years, and the classes are from like nursery to the 12th grade. This stage offers a diverse curriculum, allowing students to explore various subjects and develop interest, paving to the way for the higher education. Higher education stage, following completion of school education, students enter colleges or universities around the age of 18 to 19 years, and the duration of undergraduate programs vary depending on the field of study, typically ranging from 3 to 5 years. Postgraduate degrees are pursued thereafter, providing specialized knowledge in specific domains. And last is the doctoral stage. This is like after completion of your research
Yeah,
work.
sorry to interrupt, but yeah, I would be more interested in the actual, Your proposed work and any results
Actually,
that you.
ma'am, it's
Yeah,
like a review paper. So it's
I
just
see.
a
Okay.
comparison that what are the uses of generative and recent education which is there in India.
Sorry, can you repeat once again?
This is just a review paper for
Mhm.
like what the use of generative AI in education, how it's going to help, like ChatGPT, how it's going to help in the current scenario. It's like I've already talked about the four stages are there. Like there are students for higher studies also, lower studies also. So how this ChatGPT is going to be helpful, or it is not going to help the students or the mentors or the faculty
Okay,
there.
okay, got it.
So about the personalized learning, like adaptive tutoring, like ChatGPT can provide personal tutoring to the students, adapting its teaching style to individual learning preference and pace. And second is the customized content. It can tailor learning materials, then quizzes and exercise according to the students' needs and help them to grasp complex concepts more effectively. Now, it can give like 24 into 7 learning support. Like instant help decks are there and on-demand resources are there. Like ChatGPT can recommend additional sources such as articles, videos, or tutorials to further support students in their studies. In language learning, language practice, language learners can engage in conversation with the ChatGPT to improve their language skills, receiving instant feedback on their grammar, vocabulary, and pronunciation. Culture context, it can provide information about cultural nuances, colloquial expressions, and real life language usages. Next about the research assistance, like we can find out many of the literature contains literature reviews can be there that can aid students in conducting their surveys, summarizing the articles and producing insights to support their research projects and idea generation. It can help brainstorm ideas and provide inspiration for research topics, helping students kickstart their projects. In accessibility, assistive technology, ChatGPT can be integrated into assistive technologies to aid students with disabilities, offering a more inclusive learning environment. And in multilingual support, it can facilitate communication with the students from diverse linguistic backgrounds, ensuring that languages won't be a barrier. Professional development, career guidance, ChatGPT can offer advice on the career paths, provide information about industry trends, and assist with resume writing and the interview preparation. Skill development, it can recommend online courses, workshops, and resources to help students acquire additional skills relevant to their chosen field. Automated grading and feedback, efficient assessment, ChatGPT can automate the grading of certain types of assignments, saving educators time and allowing for more efficient feedback. Consistent feedback, it can provide consistent and objective feedback to students, ensuring fairness in the evaluation process. Collaborative learning, group discussions, ChatGPT can facilitate online discussions, providing a platform for collaborative learning and idea exchange among students. And peer review support, it can guide students through the peer review process, helping them provide constructive feedback to their peers. Now, what are the advantages of using generative AI in the education system? Like personalized learning, then content creation and enhancement, accessibility and inclusivity, efficient grading and the feedback, data-driven decision making. These are the advantages. The challenges which can be faced are like equity and accessibility issues, privacy concerns, quality of content, and lack of human touch. So in conclusion, that the influence of generative AI in education is undeniably revolutionizing, ushering in both innovative possibilities and unprecedented challenges. The potential for enhanced personalized learning, streamlined content creation, and adaptive support mechanisms offered by generative AI is substantial. Nevertheless, the integration of such technology calls for a consistent approach, prioritizing ethical considerations, including bias mitigation and privacy safeguards is crucial in shaping a fair and inclusive educational environment. Educators, policymakers, and technologists navigating this dynamic landscape must strike a delicate balance between harnessing the benefits of generative AI and preserving the indispensable human aspects of teaching. And lastly, like vigilance, adaptability, and a steadfast commitment are essential to ensure that generative AI's transformative impact on education enriches the learning experience and equips students for an increasingly technologically advanced future. These are the references. Thank you.
Okay.
Ma'am, any questions?
No questions. Actually, it was a means review work only, so no questions from my side.
Thank you.
Thank you for your presentation. So we have come to the end. I sincerely thank our authors for their excellent presentation and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on the behalf of whole team, thank you for the support during this 8th version and all the previous 7 versions of this conference. We will be happy to have you in the 9th version in 2025. All the presenters would be getting their digital certificates through email within 2 working days. Further, all the papers have already been forwarded to the stranger. The publication will be live within 6 months, and kindly cooperate with the team of ICTIS 2024. I also thank our session chair, Dr. Anuradha Yankekar, for chairing the session, and a token of appreciation to her. Thank you for being with us. Thank you so much, ma'am.
Yes, thank you, Gadi. Thanks all the participants.
So I request all the participants to please turn on the camera so that we can take a quick snapshot. Thank you so much for your presence. Thank you.
Thank you.